Okay, welcome to Advent of Code with OpenRefine Day 7. I'm getting a bit behind here. It's actually the 12th of December, but this is Day 7 of the Advent of Code. And the puzzle today is that we have a list of commands which navigate around a file system and list the content of a directory. And we have to work out essentially the size of each directory, not just the files that are in that directory, where we have the file sizes, but if that directory has any subdirectories, then we need to include those in the size as well. So we have to sum up the directory and all the directories that are below it in the hierarchy. And this, I have to admit, has been extremely challenging to work out in OpenRefine. I've had to work quite hard to understand how this could be done. I don't know if I've done it in the best possible way, but I did get it working eventually, but I had to do that. I couldn't work this out live. So let's start. So this is the puzzle input. So we have a list of commands, and the commands navigate the directory, so they change to the root directory. We get a list of all the things in that directory, and then they change to a directory, one of the subdirectories that's listed, and then they see the content of that, and then there's another subdirectory, and they change to that, and then this command here, cd ... means go back up a directory. So this goes from brmgzjp directory into, this goes from the bmzjj, no, this goes from, so this goes from the bfbjzfd directory into the brmgzjp directory, and then these dots go back up one level, so back into the bfbjzfd directory, and then the next command changes down into another subdirectory. So they're going up and down the directory structure in a relatively logical way, but it's this list of commands that we have to understand, not just the directory structure, but how to create the directory structure based on this list of commands. So let's start. So I'm going to get this into OpenRefine to start with. So let's call this commands, and this is Advent of Code Day 7. Okay. So now we have the commands in. So some of this is very straightforward. So the first thing I'm going to do is extract all the directories that are mentioned, and I'm going to do that. The directories were mentioned both when there's a file listing of the directory, and also when the command to change into that directory is given. So I'm going to extract the directories by looking at when we change into that directory, and that's because we can then group things that happen within a single directory together, which is quite nice. So let's add a column based on this column. We'll call this directory, and there are different ways we can do this, but I'm looking for essentially any command that starts cd, because that's going into that directory, and so we can do it like this, match. I'm going to do it like this because this way I can get the actual directory name. So this is doing a match, a regular expression to extract the directory name, and we get, so we just need to get that from the array. Okay, so you can see we get the directory name. If I click OK now we have a list of directory names. So here, that includes the dots when we have the moving up a directory. So I'm going to keep those for the moment because they're going to be actually important to us, because in order to work out, for example, that this directory is a subdirectory of this directory, there are two ways we can do it. We can either look at, when we list this, what are the subdirectories, or when we navigate to it, which directory were we starting from. So this tells us we're changing into the BFB JZFD, we change into BRM GZJP, then we go up one directory back to BFB JZFD, and then we go down into RHR QTTG. So we have to understand that series of events to understand that the path to this directory is actually /BFB JZFD/RHR QTTG, and that this one equally has that kind of similar path, but it's different. So that's kind of quite important to us, and it's one of the things that I've been puzzling over in trying to solve this. So one thing I can do is a little bit of a tidy up. Well, actually, one thing I can do just to demonstrate one of the problems we've got here is I can do a list of all the directory names, and if I show you by count, you can see that a directory called HMZ appears 14 times, and this is because file directory names only have to be unique within the directory they're in. So this actually means there are lots of directories called HMZ. They're just at different places in the hierarchy, so they all have a unique path to them. But it means that we can't just say like sum everything in a directory called HMZ. We have to work out like the different HMZs that are present and the value that they have. So actually what we have to do first, before we can sum up the contents of the directory, which turns out to be relatively straightforward, we first have to work out what the path to each of these directories is, the full path, not just the name of the directory, but the full path from the root down. And that is the difficult bit. We can do a little bit of tidying up. If I do a custom text facet, so I'm going to look for all the ones that contain, oh well, actually I can do where it equals $ls, because those 199, I don't care about those. They're just something saying list the content of the directory, so we can remove those. So we can start to get to a slightly more reasonable number of rows, which is great. We can also easily extract all the file size numbers, so that's relatively straightforward as well. So let's do that. And here I just care about the lines that start with a number and then anything else, and grab that number. So I don't really care about the file names. So you can see that's got the file sizes. Let's just rearrange these a little bit. So I've got the directory first and then the file sizes, and if I were to make this into a record now, you can see that these records, we now have the directory and we have the file sizes, and so what I can do is actually sum these together easily for each record. If I do a join multi-value cells here, this will get us to a point where we've got all the numbers in a single cell for each of our directories. So we've got all the numbers together in one cell, and then I can add them up by doing dot split. So that gives me an array of them. So find one with more than one in. There you go. And then we can do dot sum. Oh, but they're not numbers at the moment, so we have to convert them to numbers. And now we can do, and there you go. Okay. So now we've got the size of each directory, and actually having achieved that, we can now remove all of the rows that were about file size and all of the, we're not going to use these directory listings anymore, so we can remove everything that's not a cd command. So actually I'll just change what this one is. Value dot starts with cd. So all the ones where that's not true, we can get rid of those. Okay, so now we have a much simpler file, so it's only 396 rows now, and we can start looking at how do we find out like which to add together everything for a top level directory, which are the subdirectories. We're going to do that by understanding this sequence of commands, and the first thing we're going to understand from this sequence of commands is whether each command is going up or down a directory. So cd dot dot goes up a directory, so we're going to a higher level directory, and cd to anything else is going down one level. So we can do this by add a column based on this column. We're going to call this depth change. So if value dot, so if value is equal to cd dot, then it's -1, otherwise it's +1. So you can see here now we're going down, so we're increasing the depth by 1 every time we change, except when we're changing ... then we go up 1. So now what I'm going to do is I'm going to use this to tell me at what level in the hierarchy each directory listed here is. So the way I'm going to do that is I'm going to use the depth change to calculate, if I sum all the depth changes to the line that I'm on, then that will give me the total depth. So when I change into the root directory, I'm at a depth of 1. When I change here, I'm at a depth of 2. I change into another subdirectory, I'm now 3 deep. I change up a directory, -1, so I'm 2 deep, 3 deep, 4 deep, 3 deep, 4 deep, 4 deep, and so on. So what I'm going to do is make these into a record, so I can manipulate this whole set at once. Oh, I didn't mean to do it. Well, let's just blank these. I didn't mean to populate those. So empty string, move to the beginning, add a root, and then look at the records. So with a blank down here. Right, okay, well now we've got one record. So what I'm going to do is work out how deep each directory is by doing a sum of the depth change column up to the row I'm in. So call this depth, and so we're going to get so that's the list of all the depth change values, so either 1 or -1. So I'm going to switch away from this to just make this a bit faster so it's not trying to preview everything. And in fact, I found that sometimes this grinds to a halt if you try and preview everything, and it automatically previews. So I'm going to call this A, and then we're going to, so this is an array called A. So what I'm going to do is I'm going to iterate through from 1 to so this is saying go from 1 to the length of A, incrementing in steps of 1, and so essentially I'm going to go through each array and create a sliced array, so a subarray or a subsection of the array, which goes from 0, the first item in the array, to the ith item in the array. So essentially we're saying up until this member of the array, create a subarray that just goes up to this member of the array, and we create, so the first subarray just has one item in it, the second one has 2, the third has 3. So essentially this is the history of where we are in the rows to date, and we're going to sum that together because that's what we want, because if we add the 1s and -1s together it gives us the current depth. And then we're going to, so that's the end of the width, and then we're going, but we don't, that gives us an array of sums. So we might be able to switch back and see what that looks like. I've got something wrong here. The for range needs closing. Okay, so now that should be trying to preview. There you go. So it's the sums. So you can see 1, 2, 3, back down, 2, up, 3, 4, 3, 4. So it goes up and down. So that's the whole array, and each row has come out with the same array because it's doing the same calculation on every row. We just want to get the one from that array that's equivalent to the current line we're in, which is the row index. So we can take the row index from here, and now we get just the one from that array. So if we look at that, then we can see the depth goes 1, which is correct, then add 1, 2, add 1, 3, -1, 2, add 1, 3, add 1, 4, -1, 3. So that's the kind of incremental sum of all of those numbers. You see the last one doesn't calculate, so this should be starts at 1, so it's going down to a depth of 2 here. I should have done because I went from to the length of A, and I should have gone to the length of A plus 1 because it's 0 offset, I think. Anyway, yeah, probably that's the mistake I made there. But anyway, we've got that. Okay, so now I think we can remove this column, so we don't need the record anymore. We've got that. We've done that calculation. So what I'm going to do now is I'm going to indicate for each directory, I'm going to add into it this number. So I'm going to create a string that identifies this directory by both its name and its depth. So what I'm going to do is add the number from the depth column onto the front of this. So I'll do cells.depth value plus, we'll put in a separator plus that. Actually, I don't really want 1.0, I just want the so let's just control that conversion a little bit. So that's and I had to look this up. That's %.0f. %.0f. Okay, so now we've just got the integer number. Oh, actually, I forgot to get rid of these. We can get rid of these in a minute, but we don't care about these anymore. So I'm gonna, now we've got those, right, now I'm going to remove, now we've got this depth indicator. We don't care about the CDs anymore because we know which level each one is at. So let's get rid of all of those. Okay, so now we just have the rows that we care about, which are the directories. So we've got the total size of each directory. That was straightforward. We added those numbers together. So each directory, we know the size of its files, but we don't know the size of its subdirectories. So what we've got to do now is the difficult bit, which is create the path to each of these directories. So we can then work out which directories contain which other directories, and therefore what numbers we have to add together to get the total size of the directory. The way we're going to do this is, okay, I'm going to add back in our record column because we need to have a record for this. So let's call this record again and put in root and move that to the beginning. I didn't, should have just left that where it was in the first place. But anyway, okay. So now we're going to add a column based on this column. We're going to call this full path. To create the path, we're going to look for, so if we're, for instance, at brmgzjp, then that's depth 3. So we know that we want a second level directory before that and a first level directory before that, which happens to be the two above it in this case, but it doesn't have to be. For instance, here we're in a fourth level directory, and the next, this is the third one. There's another third one level above that, but this is third level. So we know that that is inside that. So it's the last third level directory before the one we're in, and then the last second level directory before that. And the only reason that this works is because that original list of commands is in a very logical order. They haven't kind of gone wildly around the file system. They've essentially gone up and down as far as they can. So they go to the greatest depth, and they go back up and back down. And so we can always know that I've fully explored each subdirectory before they move on. So that's what makes this possible. It's quite complicated. I've got it written down here, but essentially, so we're taking the number from the front of the directory. That's the depth number, and we need to convert it to a number, so we can treat it as a number. And we're going to create we're using for range, so we're creating a range of numbers. We're going to iterate through, so incrementing by 1 each time. So we're going from 0 to the length of the number in the row, so essentially the depth of the current directory. And then we're going to filter the list of directories We're going to filter the list of directories to the depth. So we're going to iterate through, basically we're going to filter to depth of 2, depth of 1. but we only want to include the directories that are before the current row. So essentially, if we're here, we don't want to include a 3 that's further down. We want to look for the last 3 that we saw. So we only want to consider all the 3s before this one. So this is what I'm doing here. So I'm going to slice the directory up to the current row index. And then we're getting the so this bit is taking just the list of rows up to the one we're at, and then from that we're splitting again the name into the number and directory. We're looking at the number and saying, is that equal to I, which is our iterator, and then we're going to take the last one of those. So that's -1, so the last one in that list, that filtered list. So this is still in part of the filter command. So I'll put this on its own row just to make it a bit more clear. And then we can close that for range. So now we're going to join those together with a slash. Something wrong here. So it's looking okay. We've just got that. It feels like maybe we should go from 1. No. Slice it. Maybe this should go from 1. There we go. Okay, so yeah. So we can just do some checking by eye here that we essentially start with the root. Actually, I've got a little bit of extra stuff in here, so let's just tidy that up. So we don't want ever to have a double slash, and we can also get rid of all our numbers. So we have a followed by should be a regular expression. It's not worked. And maybe we need to put this whole thing in brackets. There you go. Okay, so you can see that we're pretty much there, and then we can check. So this is level 2. We know that's from root. We now change down into this one. We can see that these are both at the same level. There must have been a cd ... in between. We can check that. So cd bfb jzfd cd brm gzjp. So that's that one. Then we should see a cd ... after that, which we do, and then into that. So this is working. This is navigates down to this, then goes back up and navigates to this, and this is the full path. Whew. Right. Now we have the full path. That one seems to have got an extra slash in. We can get rid of that. I'll just check that everything else looks okay. Okay, this one we're missing again. I don't know why. Oh, it never got a number. that that doesn't work in the last one because the array is out of bounds. And I thought that it should be 2 length plus 1. That looks good. Yeah. Okay. Now we're going to transform this to that, and then we should see that that works all right. Okay. So now we're going to do a tidy up. So let's just tidy up the get rid of these. So remove all those rows. 199 we should have. That's good. Now we're going to add our full path, which is this one. Okay, that's looking good. Just get rid of the extra one in there. Okay, so this is all looking good. I'm going to change this back to just the directory name so we can get rid of the number. Okay, so now what we're going to do is we're going to use this full path to look up for each directory which other directories it contains. So if we were to look up from this directory, the root, which other directories it contains all the ones where the full path starts with a slash, which is all of them, which is what we'd expect. If we look for like all the ones that inside this one, this contains all the ones that start with slash bfbjzfd, which is this one, this one, this one, down to here. So we know that if it starts that way, then it contains them. So in this way, we can create a column that says all the ones that it contains. So, which we're in record mode, and then we're going to do add column based on this column. So contains, and then we're going to get a filtered list of so essentially this is a list of all of the other rows which start with the same thing. So we look up all the rows that start with this, which is just itself. Or here we look for all the rows that start with this, which is this one, and 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 this one. Whereas if we look up all the ones that start with this, it's just the ones underneath here, so it doesn't include this one, because that doesn't start with the same string. So that is a list of all of the ones we contain, and that first one should be everything. So now we've got a list of all of the directories contained by this row. So this directory contains all of these directories, this directory contains all of these directories, and for each directory we have the full path. So we know that this is a list of the full path, so we're talking about this column. And then finally, all the way over here, we have the file size. So for each directory we have the file size, we know which directory it belongs to. So essentially the total size of this directory is the sum of all the file sizes from all the directories it contains. So let's get rid of this, and we're going to add a column based on this column, and this is total size, and that is, so we want to split this into one. So for each value v. Now, so we want to look it up from the full path directory. So we're looking that up and get back the file size, and we can do this with a cross command. And just if we have a look at what we get, it includes itself here. So it's a big one, but we can see that it always includes itself. So actually, we're going to get the sum of everything here. We don't have to add anything on afterwards. So for each one, we're going to do a cross against. So this looks it up in a project. So looking up it in its own project, and we want to look up against the full path. So we're just essentially looking up the value in the current project, and we if I can get the name of the project right, and we know that each time we'll get back just one row because they should all be unique. And then what we want to extract is the file size value, and then that's a list of all of the sizes of all the directories contained by the current directory row, and so we can sum those, and that is the total directory size. So let's just hide this column. That is the total size. Whew. Now the question is, so to begin, find all the directories with the total size of at most 100,000. So basically we want to know all the ones where this is 100,000 or less. So let's create custom text facet. Value is less than or equal to 100,000. That's true there. So that's the list, 25 of them, and then it says calculate the sum of their total sizes. So we need to sum these. Well, it's never. So let's we can remove all the ones we don't want. We can make a record again. We've done this so many times now across Advent of Code, and then just make that a record. And row dot record dot cells dot total size dot value dot sum 1232307, and if we have a look, hopefully that is the same answer I gave, 1232307. That was the answer. That was mammoth. And we're still not done. Part 2, we essentially have to free up enough space to have 30 million left, and units not given, and the total file size is 70 million. So we know how big the root directory is, so we need to find the smallest directory that would free up enough space. So we're going to have to restore. Okay, so then we're going to do a couple of steps because we want to restore back all the directories. So back to having all the directories. So we're no longer interested in the total size. Sorry, we're no longer interested in the 100,000 figure. What we want to do is, we know that this is the figure from the total figure, and we know from the puzzle that we need, that the total we've got is 70 million. So the total we currently have free is that figure minus that figure. No, wrong way around. That figure minus that figure. So that's the amount we need to free up. No, that's the amount we've got currently left, and we need 30 million free. So the amount that we've got to find is this amount. So we need the directory that is closest to that amount. So we want where the value is greater than or equal to that. So that's true for 9 directories. Now we can sort this with the smallest first. So this one should be the smallest directory. That would free up enough space. And the answer we have to enter is the size of that, which is 726,8994. So hopefully that is the number I put in, 726,8994. That was epic. Day 7, Advent of Code with OpenRefine.